Well, hi there, everyone. Thanks so much for showing up for your math learning. It's Mr. Jennings, and we're going to go over the Grade 9 Preparation Masterclass. The purpose of this video is to give you a walkthrough of every single skill, all of the things that you need to feel prepared going into day one of your Grade 9 D-streamed class. So, the way that I recommend you use this video and Delta Math is you're always going to copy out your questions on paper. So have a pencil and paper nearby while you're doing Delta Math. It's not a mental math exercise unless you want to make it one. So use it to consolidate your skills. That being said, with this assignment, if you master a topic, just move on. You don't need to do every single question when it's easy. Just make sure that you have all of the skills and you're fantastic, you're golden. And if you get stuck, there's a number of things that you can do. You can check a solution in Delta Math. You can check this video for advice and use the timestamps, and it will take you to the correct skill. And then you can ask a teacher, a classmate, or a parent for some help. So with that being said, let's drop in. Our first skill that we're going to take a look at is adding and subtracting integers. All right, let's go. So I've got my blank paper over here. You're going to see me working away. And we have 7 minus 10. 7 minus 10 is going to cross the 0 because we're subtracting a larger number from a bigger number. So one way to imagine these types of things is as though it's temperature. And we are up here at a 7-degree day. Here's 0. And if I go 10 degrees colder, that's going to cross the 0. How much is it going to cross by? The difference between 7 and 10. So we're going to be down there at minus 3 is our answer. So 7 minus 10 is minus 3. And submit your answer. So let's see how we did. So let's say yes, and it's correct, of course. All right, so let's say new problem. All right, this one is the same idea. We are going to be crossing the 0. One other strategy that you can use here is just turn it around but make the answer negative. So I know 6 minus 12 is going to be a negative number, and it's the same thing as 12 minus 6 but negative. 12 minus 6 is easier to do, so it's 6. You see these numbers just switch spots, but I know the answer is negative. Okay? So negative 6. So it's a different way that you can approach these. All right. Okay. If we have ones like this, though, this can get tricky for students. So if you feel tricked by this, you're not alone. Don't worry. 1 minus minus 8. Well, subtracting a negative is weird. So what we can do here is remember that subtraction is the same thing as adding the opposite. So the opposite of minus 8 is 8, positive 8. So instead of subtracting negative 8, we could add 8, and that would be the same thing. It's 9. So this one is 9. And that's how I would approach these types of questions. Let's move on to adding and subtracting integers. This one is your speed-based practice to see how quickly you can do these things and to help you build your speed. You're going to like having better speed. So what I would do here with minus 5 plus 6 is I like to move these around. This can move over here and this can move over here. Plus 6 minus 5. Well, we don't really write that leading plus, so it's the same thing as 6 minus 5. It's 1. Right? Minus 7 minus 5. We are a very cold day. Here is 0. And we are at, this is my thermometer, this is minus 7, and we get 5 degrees colder. Minus 12 is 5 degrees colder than minus 7. Okay, 2 minus 8. Again, it's the same thing as 8 minus 2, but it's negative. So it's negative 6. Right? And so you can use these to practice your skills and build your speed. Next, adding and subtracting positive and negative integers is more time to practice for you. But again, it involves these types of situations where we have minus 3 minus minus 2. And then I can say, well, that's the same thing as minus 3 plus 2 because subtraction is adding the opposite. And this is the same thing as 2 minus 3. I can move them around if I want. And a 2-degree day that gets 3 degrees colder is -1. -2 minus -5. Again, they're tricking us with this funky way of writing things down. -2 minus -5. But we're not tricked for too long. That's the same thing as -2 plus 5, because subtraction is adding the opposite. So we change it to addition and add the opposite thing. And I can even rewrite that as 5 minus 2 as 3. There, so you can get some practice there. And try those. All right, that brings us to the end of subtracting, adding and subtracting positive and negative numbers. Now we get to multiplication and division of integers. So let's take a look. Multiplication and division of integers, this is tricky where we have signed numbers and we don't know, is our answer going to be positive or negative? So the real trick to knowing how to do multiplication and division of integers correctly is you just count the number of negatives that are in the problem. If I have 11 divided by 1, that's just positive 11. Okay, that's just 11. All right? But if I had negative 11 divided by 1, that should change the answer, because it's negative. This is now negative 11. If I had 11 divided by negative 1, well, that's also changing the answer from this, right? So it should be negative 11. And then if I had negative 11 divided by negative 1, that should change the answer again. It's now positive 11. So here's the trick, all right? In all of these cases, you just count. Here we have 0 negatives. And 0 is an even number, so that means we have a positive answer. Here we have 1 negative number. Here and here, 1 negative means we have a negative answer, because 1 is odd. Okay. Anytime you have an odd number of negatives in your multiplication or division problem, your answer is negative. Over here we have 1, 2 negatives, and that gives you a positive number. So when this number is even, your answer is positive. Okay? So let's walk through some of these. We would say this answer would be negative because this is a division problem and one number is positive and one number is negative. When you have this situation, you are negative. Yes, good. New problem. So negative 8 times 3. The answer would be negative because this is a multiplication problem, and because we can see it's multiplied. It's negative 8 times 3. And one number is positive and one number is negative. There you go. So that's why that's true. And then let's keep going. Here this is again negative because we have one negative number. Negative because we have one negative number. Why is it only giving me this type? There. So here you have positive number times positive. So there we would be positive because this is a multiplication problem and both numbers are positive. Cool. All right, and you should get a wider variety of problems. So here we go. Negative 10 divided by negative 6. Here our answer would be positive because this is a division problem and both numbers are negative. When both numbers are negative, you get a positive because you're in this situation. Two negatives, they cancel. Pyong, pyong. Yay. So that's really only reviewing what sign will the answer be. Once you've figured out what sign the answer is, then you can go ahead and use your calculator to solve the problem. Minus 6 times minus 3 is positive, and 6 times 3 is 18. 30 divided by 5 is 6, but the answer is negative because it's negative. 49 divided by 7 is 7, but it's negative because there's one negative here. 24 divided by negative 6, well, 24 divided by 6 is 4, but the answer is negative because there's one negative. So this is the opposite, is 6, but negative. This one is positive 6 because negative 20 divided by negative 4 is 6, and it's positive because there's two negatives. What? Yeah, well, oh, but it's 5. That's fun. Yes, of course the answer is 5, because 20 divided by 4 is 5, not 6. Why did I say that? I got hypnotized, I think. I think I was hypnotized there. Okay, that's fun. All right, go back. Okay, so now we get into PEMDAS or BEDMAS or this BOMDAS or BEDMAS. Okay, there's lots of different ways to say order of operations matters. So with these types of problems, copy them out as you see them. So let's go. I'm ready to copy here. Minus 6 times minus 4, end the bracket, plus negative 1 times 8. Okay, so we must do operations that are inside brackets first. So we can do the operation inside here. Minus 6 multiplied by minus 4 gives us 24. Okay, and then we're going to be plus negative 1 times 8. Next, we have to do multiplication next. So that's here. This is multiplication, so we have to do that next. 24, and we can say this is equal, and this is equal to what we have upstairs. This is equal to negative 8, because minus 1 times 8 is negative 8. 24 minus 8 is 16. 16 is our correct answer here. So we have to follow this series of operations. Parentheses, exponents, multiplication or division. It says left to right, but to be honest, you can generally do these things in any order. Things are written nicely. And addition or subtraction, again, in any order that's convenient, but they say left to right. That's fine. They get to the same place. They do exactly the same thing that I did. So you can always check when you get an error and go in here and find where your error was. That's what learning looks like. All right, let's do another one. So here, I have to do brackets first. So 10 times 9 is 90. So let's copy this out. And I can even copy it at one of those intermediate steps, right? Like I could say here plus 90, but I'll just do 10 times 9. I'll do the whole thing. Okay, so this is equal to minus 1 minus 2 plus 90. And then minus 1 minus 2 plus 90. Here I can do minus 1 minus 2. If it's a minus 1 degree day that gets minus 2 degrees colder, that'd be minus 3. Minus 3 plus 90 is a little weird to think about, so I'm going to move them. 90 minus 3 gives me 87. So with these, go along and follow brackets first, then exponents. And these problems won't have any exponents in them yet. So you won't need to worry about that. And then multiplication, then addition, subtraction. That's it for those. When you have exponents, then we have to do the exponents before other operations, but after any brackets. So let's try this one. With these, there's just like extra things to keep track of, so slightly more challenging. 6 divided by negative 2 plus 9 squared minus 2. Okay, so I have things that I can do inside this bracket, so let's go. This will be equal to 6 divided by negative 2. I hate this sign. I never use it, and your grade 9 math teacher probably won't either. So getting used to turning it into that is not a bad thing. Plus a 9 squared. We have to do the squared first inside the bracket, because even though we're going to do the stuff inside the brackets, we still follow BEDMAS inside the brackets. So 81 minus 2 is there, because 9 squared is 81, and minus 2 is minus 2. So this is equal to 6 divided by negative 2. We're just going to leave that for now because we have brackets yet to do. 81 minus 2 is the same thing as 79. That number just busts out of the bracket, ready to party with the other numbers. 6 divided by minus 2 is negative 3, because 6 divided by 2 is 3, and there's one negative, so it's negative. Negative 3 plus 79 is a little awkward, so I move them around. 79 minus 3, that is the same thing as 76. We were almost there. We almost had our first 6, 7 of the video. So that's how we would work with exponents and BEDMAS. All right, now we're going to get into fractions. Great, good time, fractions. All right, I'm going to get myself some fresh blank pages here. Going to need those pretty soon. Oops, wrong one. There. Okay, I think I'm ready. All right, let's take a look at fractions, everyone. So one thing to understand is that fractions, we can write them in multiple different ways, and they all mean the same thing. So we've been asked here to take this fraction, 8/20. We can imagine like a chocolate bar that had 20 pieces. Okay, so I can draw that chocolate bar for you pretty quickly. There's a chocolate bar with 2 pieces. There's a chocolate bar in 4 even pieces or quarters. And then if I cut these like this, you'll see we're in 20ths. Look at that, I cut it 5 ways one direction and 4 ways another direction. And so this is like saying, imagine we had 8 of these 20ths. So I'm just going to shade those in. So like here's 8 of those 20ths. Well, that's the same thing as 2 out of 5, right? These 2 full rows are shaded out of 5. So visually I can see 8/20ths, right? Like that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 of them. That's 20 pieces. If I have 8 of those pieces, it's the same as having 2 out of 5 big pieces. So what we can do here is you can divide this number by 4 and divide that number by 4, and you end up getting the equivalent fraction, which is 2/5. So 2/5 is exactly the same thing as 8/20. It's just like your chocolate bar's been cut into more pieces. It's the same amount of chocolate. So you're going to go ahead, you're going to put that there, you're going to submit the answer, and you're going to do this. You're going to pat your back. Oh, they did the same visualization as I did. Wow, that's so cool. Okay, so this is a really key skill. And if you understand this, you'll understand a lot about ratios and the different ways that we do this. So here we have 2/8. 2/8, if we divide 2 by 2, we get 1. If we divide 8 by 2, we get 4. So 2/8 is the same thing as 1/4. You need to have this skill so that you're confident with fractions. So we can also scale up fractions. So if I want to scale this fraction up by a factor 11, that's a little bit like saying, someone said, how many guests are we having? Oh, we're having 3 guests. Oh, okay. All right, we're going to have 3 guests today, so I'm going to cut this pie, this cherry pie, into 3 even slices. See my 3 perfectly even slices? And then someone says, oh, wait a minute. It's not 3 guests. It's 33. Okay, there's 33 people coming. Oh my gosh, we need 11 times as many pieces. So I'm going to cut that into 11, I'm going to cut that into 11, and I'm going to cut that into 11 pieces. So now I'm out of 33 pieces. And if I had 2/3, because you see we're interested in 2/3 over here. If I had 2/3 of them, that would be 11 plus 11. Or 22 33rds. All right. So when working with something like this, you're not going to draw pictures. Okay. Well, you can, but we're just going to multiply by 11 on 11. And when you multiply fractions like this, that's 2 times 11 on the top. You just do top times top over bottom times bottom. 2 times 11 is 22. 3 times 11 is 33. There's what they're looking for. All right. So you see there, they showed it with the chocolate bar model. It's the same as I'm showing you. Okay, so that's that skill. Super key skill, super important. All right, let's keep going. So this is similar to this idea of fraction equivalence, and here is some timed practice, so you can build your speed with this. We want to find an equivalent fraction to that. 6/8 is equivalent. How did I know that fast? Well, no, it's not. Yes, it is, because this 15/20 is the same thing as 3/4, and 3/4 scales up to 6/8. So how are you going to do this? Okay, so you can do things like 15 on 20. Okay, I see that both of these can be divided by 5. Okay, and that gives me 3/4. And then I can multiply by the same thing top and bottom, 2 on 2. That gives me 6/8. There. 5/8 is the same thing as 10/16. I would multiply top and bottom by 2. 4/10 is the same thing as 2/5. Divide top and bottom by 2. 12/16 is 3/4. And 3/4 is the same thing as 15/20. Sounds a little tricky. 7/14, that's 1/2, right? 7 on 14, I can divide here by 7, top and bottom, and that gives me 1 on 2, so it's 1/2. Okay, so that's how that one do. And that's how you can practice and build up your speed and things. Okay, let's keep going. Now, another skill is like really just understanding what a fraction is. So we have this fraction a, and it's on this number line here, and we want to know what fraction that is. That's a number line. That's a number line between 0 and 1. There's all kinds of numbers between 0 and 1. Okay, so here's my question, 1 and 0, and it goes that way, and a is over here, and I see there's a mark there, a mark there, a mark there, and a mark there. So I count them. There's 1, 2, 3, 4, 5 steps. So we have divided the space between 0 and 1 into 5 pieces, and this took 1, 2, 3 of them to get to A. So this is the same thing as 3 on 5, 3/5. A is 3/5 the way to 1. Okay, let's do a new one. This is 1/2, because I see that there are 2 jumps between 0 and 1. So the answer is 1/2. Yeah. This one, count the jumps, 1, 2, 3, 4, 5, 6, 7, and A is at 5 of them, so this is 5/7. Cool. There, cool. This one is 1/3. There are 3 jumps, and A comes at the first jump. So that's just very quick. Let's make sure we know that a fraction is a number in between numbers like 1 and 0. Mixed numbers on the number line, on the other hand. Here we have some number of jumps between each number, so I'm going to count them there. We have 1, 2, 3, 4, 5, 6, 7, 8. There's 8 jumps between the number. A is 7 out of the 8 jumps there, but we also have 4 before we get there. 4 whole numbers like 0, 1, 2, 3, 4. 4 wholes, and then 7 small jumps. So 4 plus 7/8 is the same thing as 4 and 7/8. So get some practice with that and get comfortable with this idea of mixed numbers. Okay, cool. So same idea. We can play an animation there if we want to see 2, 4, 5, 6, 7. There, blah, blah, blah. Okay, so those are those. Well, let's try another one. Okay, here we have 5 wholes, and then I check and each number has been divided up into 1, 2, 3, 4, 5. So we are 5 and 4/5. And that's the way we write those numbers. Cool. Okay. Next, so whole times a fraction. All right. When we are multiplying integers by fractions, this is a really key skill. Comes up a fair bit. It's like saying, I have 4 friends, and I gave each of them 4/5 of a chocolate bar. How many chocolate bars in total did I hand out? To do this type of problem, oftentimes students will write the integer as a fraction. 4/1 is the same thing as 4. Dividing by 1 doesn't change a number, so we can write it that way. And then when we do 4/1 times 4/5, we are going to be equal to 4 times 4 on the top, which is 16, and 1 times 5 on the bottom, which is 5. 16/5 is our answer, and we're done. We would like to give reduced fractions as our answer wherever possible, but I'm noticing that there's nothing I can divide 5 by and divide 16 by where I don't get some kind of weird number. So we're done. This is 16/5. Oops. 16/5. Let's go. Yeah. Yeah. All right. Now, let's keep going. Okay, no problem. So 6 times 1/5. Okay. 6/1 is 6. And we're going to multiply by 1/5. 6 times 1 is 6. And we have like 6 times 1 on the top over 1 times 5. Do both of those. 6 times 1 is 6. 1 times 5 is 5. Our answer is 6/5. That's it. No problem. This is a little better problem. There's a little more we have to do with this one. So 30 multiplied by 1/8. I can write that 30 as 30 over 1. And then I just do top times top over bottom times bottom whenever I'm multiplying fractions. So here, 30 times 1 on the top and 1 times 8 on the bottom gives me 30 on 8. But then I notice something about the numbers 30 and 8. 30 is the same thing as 15 times 2, and 8 is the same thing as 4 times 2. That is to say, I could divide this by 2. No, it's not 2 divided by, that's annoying. I really hate that sign. But I'm using it today for some reason. 30 divided by 2 is 15. 8 divided by 2 is 4. So our real answer is, these cancel. 15 on 4 is our best answer. That's our reduced fraction. Let's see. So then we walk it through. Okay, so 30 times 1/8. So we're going to have 30/8. We add them all together. It's got this amazing animation here. And so 30 times 1 is 30 pieces, 30 on 8. So they would have taken 30 on 8 as the final answer, but my solution was 15 on 4. Mine's better. Okay, and that's the solution you're going to want to give in a grade 9 classroom. Let's look at part numbers, part marks, if not. But okay, here's a really cool thing that we can do when we're multiplying fractions. It's this idea of cross cancellation of fractions. So when we are doing a fraction multiplication, we know that we have, like, is here 28 over 10 multiplied by 5 over 16, and I can go ahead and I can notice, like, I have a 5 and a 10 on the top and the bottom. So we're going to end up in this situation, right? 28 times 5 over 10 times 16. Anytime you have something like 5 divided by 5, that's just 1. So we can cancel these away. They cancel away to 1. All right? So here, I could rewrite that 10, 28. Maybe I can rewrite that 28 as 4 times 7, and the 5 as just like times 5. So that's 28 is 4 times 7, 5 is 5, 10 is 2 times 5, and 16 is 4 times 4. Now, anytime you see the same number top and bottom, you may cancel them. So this 5 can cancel that 5. This 4 can cancel that 4. And then we're done all our cancellations. I just said something that's not true. When you have only multiplication in your numerator and your denominator, and you have the same number top and bottom, they can cancel. Okay? Things need to be connected by multiplication for that to be true. If you have addition or subtraction up there, don't do this. So this is 7 over 2 times 4, and that's the same thing as 7 on 8. Let's see how they do it, because they're going to do it a little bit differently. So here we're asked to click on the numbers that we want to simplify. We're going to say try. We're going to write the numbers as having canceled out or simplified a common factor. This is 2, and this is 1, because they both share 5. So I just try. So now it's simpler. Now I'm going to select this pair of numbers, and I say try. So there I have a 7 left, because I'm canceling out a 4, and there I have a 4 left. I say try, and then it's done. And then enter the simplified product. 7 on 8 is our simplified product. Submit answer. Yes. All right. So let's go. No problem. Let's do another. Okay, so this one, 50 and 10. Again, I'm going to try canceling out something there. I'm going to try that. 5 divided by 10 is the same thing as 1 divided by 2. This is another way to think about it, actually. If you ever have numbers top and bottom and everything is multiply, then you can do this, like 5 over 44 times 100 over 10. Well, this is the same thing as like 5 over 10 times 100 over 44. You could just swap the position of the numbers on the bottom. And then 5 over 10, you've already practiced dividing both of those by 2. And you know that dividing both of those by 5 by 2. And then you end up with 1 over 2. So that's what we've got there, 1 over 2. So we say try, and it's good. And then 144. This one is the same thing as 25 times 4. And this one is the same thing as 11 times 4. So these 4's can cancel. So we're going to simplify those. And that's 11. And that's 25. We say try. And then we're left with 25 on 22. There's nothing left that can simplify. So that's that skill. And it's a really cool skill once you cultivate it to a quick level, because you're going to be seeing a lot of multiply and divide fractions. You're like, this one is just 3/7. I can see that right away because I cancel those 8s. And then I'm left with 3 on top and a 7 on the bottom. So let me write it out, and I'll show you. 8 on 7 times 3 on 8. Cancel, cancel. This is the same thing as 1/7 times 3 on 1. That's the same thing as 3 on 7. Huh? What? What's its deal? Am I off the internet or something? Oh, it's done some weird thing where it's hanging. I don't know what happened. Oh yeah, I just like logged out or something. Okay, one moment, I'll get everything back. Hey. Okay, let's finish up multiplying and dividing fractions, and I'll make a new video with the other skills later. So here we have 3/7 divided by 10/3. So this is new. We haven't seen this yet. When you are dividing fractions, we KFC, we keep flip change. Okay, it's a finger-licking way to divide fractions. 3/7 divided by 10/3. Don't go ahead and cancel, because actually what we do is we keep the first one, you flip the second one. So here's keep the first one, here's flip the second one, and change to multiply. Okay, now there ain't nothing top and bottom that can cancel. So we just end up with 3 times 3 on the top and 7 times 10 on the bottom. 3 times 3 is 9. 7 times 10 is 70. Yay! So let's keep going. Do another one. One more. 2/5 divided by 1/2. Okay, what's half? So it's going to be 4/5. So here, 2/5 divided by 1/2 is keep, flip, change to multiply. KFC. Okay, 2 times 2 is 4. 5 times 1 is 5. 4/5. So that's how division and multiplication of fractions do, and there's lots of great tricks and skills inside this cross cancellation of fractions idea that's going to be very useful to you. All of that's going to help you when you get into adding and subtracting fractions. Adding and subtracting fractions actually involves multiplying your fractions to scale them up and scale them down first, and we're going to have easy work of that if we're strong at multiplying and dividing fractions. Thanks so much for showing up for your math learning, everyone. There'll be a second video where we go over the other topics that we haven't covered yet. And yeah, I salute you for working hard on your math and getting ready for grade 9.